and get general views, prepare the background so that second semester when we start the deeper ones, you will be all right. Sorry, here my glasses are getting fogged again and again. I think I will start my mini fan. Okay, now it may be better. So anyway, this is introduction to the construction because second sem you will do construction to understand how the framing system is created, how it is joined, and so on. You know how the load is taken at different points on the ship. So same way we will be introduced in construction, and along with that you will be doing all stability, navigation, chart work, etc., etc. Rules of the road, and then you it become deeper and deeper as you go. So now let us have one video on ship construction. Now understand one thing. Even though we have hypothetically created a framing system and then we attach the plating on top of it, this is not actually how it is done today. This used to be once upon a time the frames were actually forged and all. Okay, those were the barges and all smaller ships, but framing was created, metallurgical issues were there, and lot of things. Welding was not there. They started with riveting. So regulations came from those days, riveting. Riveting means you put two plates, drill a hole, and put a rivet in it. And that is how you hold the plates together, along with the frames also. So those frames were created, they were forged, and then they were put. That's why you will find in construction book also today also you have got stern frame and all. But on a modern ships, the frame it's impossible to forge such width, 40 meters, 30 meters width, and the longitudinal is so much. You are not going to get one piece of that length. So what happens is today it's all made in sections. You cut the ship in pieces theoretically on paper and give one job to one team, and then there is the coordination. So you can create a ship like for example, uh, long back those ships are already I will say 20 years old, more than that, probably scrapped also. They were built in Korea, and from the first plate when you break the coconut they have got different method of doing it. They use champagne bottle and all, and the first plate is laid and like puja. From there to deliver ship 3.5 months in just over 100 days to deliver with completely ready. Now, how can you achieve something like that if you go one by one plate welding? You cannot. So it is cut in pieces theoretically. Each team makes the section perfect measurements. Small minute allowance will be there for that those are metallurgical issues and all while welding and all, and then they just join them together, one piece second piece, weld it internally externally and join the pipelines, etc. So this is how the ships are built today. So here what we are going to do is we are going to see three videos, one on ship construction, other one is what stresses are generated on hull when ship is sailing. Water level goes up and down, so buoyancy increases on a spot, decreases on a spot, so there is a stress like that. And shipbuilding in Japan, okay, shipbuilding in Japan is showing you something. It is done same way all over the world today. Once upon a time Japanese innovated things. Today everybody is doing same thing, including Cochin shipyard and all. But unfortunately we as Indians don't work well in teams. We somehow start competing, not complementing each other. We start competing with each other. And then the success rate is low. That is the reason, in spite of having all the facilities available, we are not become a big power in ship construction or something. We're still talking about it. And actually, it's not complicated, you will see. The ones the welding, everything is decided which weld and all. And it's a welding is a separate branch of physics. Huh? It is a branch itself. Okay, so let us start with this. And now I think we have got 37 people in, so let's start. Okay.
Of the ship. The foremost end of the bow is called the stem.
This is
The
an
foremost
old
compartment
one,
in the bow of the
but
vessel is
it will
known
give
as
you
the
some
forepeak.
idea first what it
It is
is, the
separated from
traditional
the
one.
rest of the A division by a collision bulkhead. Other bulkheads divide the A division into separate compartments. The B division is often referred to as the machinery division. It is here that the engines and boilers are installed. The C division, like the A division, is divided by bulkheads into a number of separate compartments. The after end of the ship is called the stern. This is the rudder. These are propellers. We now have the decks to
This is
locate
the
and
twin screw.
identify. The highest complete deck extending from stem to stern is called the main deck. This complete deck immediately below is called the second deck. And this is the third deck. Between complete decks, where vertical heights permit, there may also be a partial deck. This is known as a half deck. Below the lowest complete deck are other decks. These are called platform decks.
Now this
Or,
is
more
about a
commonly,
naval ship, so
the
don't
first
get yourself confused,
platform,
okay?
the second platform, and so on, numbering downward. The space below the lowest deck is known as the hold. It is used for the storage of ballast, cargo, and stores. On drawings and blueprints, positions on a ship are indicated by lines, abbreviations, symbols, and notes. This blueprint identifies a certain floor. To locate its exact position in a ship, we must refer to the frame line, indicated by this number, the water line, and buttock line.
Sir,
Yeah.
so we need to see it
In
from
reading
beginning
this
or from
blueprint, it must be remembered
middle only.
that
What?
all these lines should be considered
Sir, it
as
started
planes.
from middle. Actually, the video started after 40 minutes.
Okay. Sorry.
Our first clue is frame line number 100.
Because this is the naval ships video, I was just checking it out. It explains lots of things better. Sorry, my mistake.
Modern steel ships are of different types, but they all have many things in common. This cargo ship has a keel, and so has every other ship. This aircraft carrier has a bow and a stern, and you'll find them also on a destroyer, or a cruiser, or a battleship. If you're in the Navy, or working around ships, your first job is to learn the names of things, what they're called, and where they belong. Much of this information is given on a ship's plans or blueprints. The first time you look at a blueprint, it's likely to strike you as a confusing jumble of lines, symbols, abbreviations, and notes. But they all mean something, just like the markings on a city map. The aim of this picture is to provide you with an elementary ship's directory. All ships are built to precise measurements, and since you can't take measurements without a starting point, certain lines must first be established as a guide in determining any given position. The first line to be established is the baseline. From this baseline, all heights or vertical measurements are calculated. The second is the center line. From this center line, all widths or transverse measurements are taken. The baseline and center line must always be considered as planes at right angles to each other. The baseline plane extends from an established point at the base of the ship. The center line plane runs the length of the ship midway between the two sides. On a blueprint, viewing the ship head-on, this line would indicate the baseline, and this, the center line. Note the symbols BL and CL. For convenience in locating and measuring heights above the baseline, a series of horizontal lines is established. They are called water lines. For convenience in measuring cross or transverse distances, there are also vertical lines, called buttock lines. All water lines and buttock lines are actually planes, subdividing the entire ship into long strips or sections. Since water lines are measured upward, they are marked in terms of distance, or the number of feet from the baseline. Buttock lines are also marked in terms of distance. In this case, the number of feet from the center line. On this simplified blueprint, these lines would indicate water lines, and these buttock lines. Note the symbols. In order to show the shape of the ship, one other set of lines is required. They are spaced at regular intervals between the forward and after perpendiculars, and they are called frame lines. Frame lines are actually vertical planes cutting across the ship at right angles to the center line plane. The frame lines are usually numbered progressively from the forward end to the after end of the ship.
Now this is the different than
Distance
what we
between
do.
frame lines varies with different types of ships. Once the three sets of lines are established, we can locate, by referring to these lines, any point on or in the ship. Perhaps the quickest way to gain a working knowledge of ship's terms and symbols is to study the ship's structure. At the very base of the ship, where the base line and the center line intersect, two long steel members provide the backbone of the ship. This flat steel member, usually so placed that its upper surface touches the baseline, is known as the flat keel. Its symbol is K. This vertical member, joined to the flat keel at the center line, is known as the center vertical keel. Its symbol is CVK. Both the flat and vertical keel run the entire length of the ship. Joining the flat keel on either side is the bottom plating of the ship. These members, coming in now, have rather a tricky name. They rise straight up, like the walls of a room, but they're called floors. As you see, they are joined to the vertical keel, and they fasten to the bottom plating of the ship. Note that certain floors are closed floors. Others are lightened in weight by means of lightening holes. These are known as open floors. Extending through the length of the ship are other members, known as longitudinals. Floors and longitudinals divide the bottom of the vessel into spaces known as bottom compartments. They may be used for the storage of fuel oil, fresh water, or saltwater ballast. Or some of them may be empty or void. Steel plating laid over the floors and longitudinals forms an inner bottom to the ship, and that's what it's called. The symbol is IB. Another name for this plating is the tank top. Both terms should be easy to remember. These vertical members, which are joined to the floors by means of brackets, are the frames. They give shape to the ship. Frames of this type are installed for the most part in cargo-type ships. On certain warships, cruisers, for example, floors run up to the underside of the lowest complete deck. Above the lowest deck, deep frames known as web or belt frames are spaced fore and aft throughout the length of the vessel. The outside plating or skin of the ship is known as the shell plating. Each lengthwise series of plates is called a strake. The various strakes are lettered in alphabetic order, starting at the keel. Incidentally, the letter I is generally left out, since it might easily be confused with J. Note that the A strakes, joined to the flat keel on either side, are called the garboard strakes. Note also that the topmost strakes, in this case the J strakes, are known as the shear strakes because they follow the shear or longitudinal curve of the ship's profile. At suitable locations in the ship, there are vertical members known as bulkheads. Those you see now are known as transverse bulkheads because they run across the ship. Other bulkheads run lengthwise with the ship and are called longitudinal bulkheads. Together, these two sets of bulkheads, transverse and longitudinal, divide the vessel into numerous compartments. Between opposite frames at various levels, there is another set of connecting members, known as deck beams. These support the decks and tie the sides of the vessel together. Reinforcing the deck beams is a series of girders running lengthwise with the ship. These are known as longitudinal or fore and aft girders. Upon this network of beams and girders is laid the deck plating. The center strake is the A strake. Then, moving outboard or toward the sides of the ship, the strakes are lettered in alphabetic order. The outermost strakes are known also as the stringer plates. All of these structural members, the keel, the floors, the longitudinals, the inner bottom or tank top, the frames, the shell plating, the bulkheads, the deck beams and girders, and the deck plates go to make up the hull. If we divide a ship into two parts at the center line, Everything to the left of the center line, looking forward, is the port side of the ship, and everything to the right is the starboard side. As we have seen, any lengthwise position in a ship is first established in terms of the nearest frame line. Midway between the forward perpendicular and the after perpendicular is the midship section. Note this very distinctive symbol. On a ship, anything ahead of the midship section is identified as forward, or fore. Anything to the rear of the midship section is identified as aft, or after. The middle portion of the ship, whether forward or aft, is commonly referred to as midships. However, all naval vessels are divided more specifically into three principal divisions: A, B, and C. These three divisions are separated from one another by transverse bulkheads. The A division is at the bow of the ship. The foremost end of the bow is called the stem. The foremost compartment in the bow of the vessel is known as the forepeak. It is separated from the rest of the A division by a collision bulkhead. Other bulkheads divide the A division into separate compartments. The B division is often referred to as the machinery division. It is here that the engines and boilers are installed. The C division, like the A division, is divided by bulkheads into a number of separate compartments. The after end of the ship is called the stern. This is the rudder. These are propellers. We now have the decks to locate and identify. The highest complete deck extending from stem to stern is called the main deck. This complete deck immediately below is called the second deck. And this is the third deck. Between complete decks, where vertical heights permit, there may also be a partial deck. This is known as a half deck. Below the lowest complete deck are other decks. These are called platform decks, or more commonly, the first platform, the second platform, and so on, numbering downward. The space below the lowest deck is known as the hold. It is used for the storage of ballast, cargo, and stores. On drawings and blueprints, positions on a ship are indicated by lines, abbreviations, symbols, and notes. This blueprint identifies a certain floor. To locate its exact position in a ship, we must refer to the frame line, indicated by this number, the water line, and buttock lines. In reading this blueprint, it must be remembered that all these lines should be considered as planes. Our first clue is frame line number 108. Since frame lines start at the forward end of the ship, number 108 tells us that the floor is pretty well aft. Our next clue is provided by the word port. This sends us to the left-hand side of the ship looking forward. Our next clue is provided by these buttock lines. We know that buttock lines are measured outboard from the center line. final clue is this 2-foot water line. Here, then, is the precise location of this open floor. All lines coincide exactly. Now let's try something different. The job called for here is to locate a hole for a pipe through a transverse bulkhead. Our first clue is number 110. This number identifies the frame line. Here, then, is the bulkhead at frame line 110. Our next step is to locate the hole. The blueprint shows that it is 3 feet 3 inches outboard from the 4-foot buttock line. We measure outboard the indicated distance and strike a vertical line. The blueprint further shows us that the hole is 1 foot 3 inches above the 4-foot water line. We measure upward the indicated distance and strike a horizontal line. Here, at the intersection of these lines, is the center of the hole. One final task, to locate a seacock. The blueprint shows that it is centered on the shell of the ship, 2 feet aft of frame line 22. First, we locate frame line 22, which is pretty well forward and in the A division of the ship. We measure 2 feet aft. Note that the blueprint reads, port side looking aft. Now we are looking aft, or toward the stern. Since we have faced about, port is no longer on our left-hand side, but on our right. The blueprint also shows that the center of the Seacock is 1 foot 7 inches above the 8-foot water line. We locate the 8-foot water line on the port side of the ship. Now we measure up 1 foot 7 inches and strike a water line. Here, where the water line meets the shell, is the exact location of the Seacock. And now let's double check. The blueprint shows the Seacock to be 3 feet 3 inches outboard from the 8-foot buttock line. Measuring outboard the indicated distance, we again come to the exact location of the Seacock. Remember then these 3 sets of lines, the base line and parallel water lines, the center line and parallel buttock lines, the perpendiculars and parallel frame lines. Keep these 3 sets of lines well in mind, and you have an essential key to your ship's directory.
Oh. Okay, now this is American film made during the Second World War. That's why you see it's black and white, and it is a film, not videos and all. And they explain certain things well, but American terminology is different than our terminology, because ours is British based and Americans like to have their Americanism, so they use the choice of words is different. So this is where you also need to be careful when you get any information from internet, because internet is fairly dominated by Americans, and if somebody has published article, you read that. Now he is using little different terminology than ours. Over a period you will learn both, so you have to be clear about what it is. Now here see, Americans measure framing from forward to aft, we do it aft from forward, aft to forward. So there are things. Now this one was a naval ship, so there are a lot of this horizontal decks and all, because they will have a large number of people on board. Seacock is actually a valve, opening from where the seawater comes in the ship, and the valve or a tap, only taps because those are the smaller ones, but we call them valves. Or seacock is also one of the valves that allows seawater to come in, because you need seawater for many things, engine cooling, lot of stuff. So this is where certain differences you are going to get when you refer to film. Now, depending on which country, like later on, you will even learn there are two different voyage systems. We keep red on the port side. Americans keep green on the port side. So like that. So you get some variations that you must know the variation. That's all. Now we will go through another video which shows the stresses on the hull. Like I told you, what all things happen when ship is sailing. The hull gets stressed. After all, it is carrying weight. It is floating with different forces acting against each other. So let us see this one. Okay. This is a good website, Marine Online. There were lots of these small videos.
The learning objectives of this section are to make shipboard operational personnel familiar with the external forces experienced on a ship hull in still water due to cargo loading, the external forces experienced on a ship hull due to sea forces from wave actions. A ship's structure may be considered as the material that provides the strength and stiffness to withstand all of the forces that the ship may reasonably be expected to experience. The hull girder, comprising fore and aft ship and cargo areas, must have the strength to withstand the full range of internal forces from sources as light ship weight, fuel, cargo, and ballast. The hull girder must also withstand forces occurring during launching and dry docking, and as a result from sea forces like slamming, racking, and thermal effects, as well as sloshing in partly filled tanks. Static forces are set up by general cargo, dry bulk cargo, liquids in tanks, the sea. Static forces from general cargo are transferred to the adjacent structure only in the vertical direction, while liquids in a tank set up static forces like pressure differences, which act in all directions. The effect of static forces from dry bulk cargo will be in between forces from general cargoes and liquids. Grain, for instance, will affect both horizontally inclined and vertical surfaces. The static sea pressure acting on the submerged hull will balance the static weights of the ship and cargo. Since the forces are not evenly distributed along the hull, forces have to be transferred and bending of the hull girder will take place. When the hold is unloaded, the surplus of buoyancy will put the double bottom in a hogged mode. With a partly loaded hold, the double bottom may be straight. When the hold is completely filled, the double bottom is sagged because the cargo weight is greater than the seawater pressure. The side shell will also deform because of the increasing seawater pressure on the side shell and the hopper acting like the so-called fixed point. Dynamic forces will primarily act in the same plane as the static forces. If they work in the same direction, the dynamic forces will be added to the static forces. The dynamic forces are set up by the water particles surrounding the ship. The hull girder, as well as the local elements, is affected. The largest dynamic forces are experienced in the bow area. Dimensions of the structure based on worst case considerations. For the hull girder, worst case with regard to the effect of forces and moments due to regular waves is when a wavelength between the crests is approximately equal to the length of the ship. The dimensioning of the hull girder longitudinal strength is based on the maximum design loading condition and wave conditions, causing highest stresses in deck and bottom. The worst case considerations are when the wave crests are fore and aft, the ship will be in sagged condition. If the wave crest is amidships, the ship will be in extreme hogged condition. Additional stresses originate from pounding and panting conditions. Bearing the brunt of the wave encounters and having the largest combinations of pitching and setting movements, the foreship is naturally exposed to dynamic forces. Three types of dynamic forces are considered. Slamming, in way of flat bottom forward at light draft. Impact pressure forces, in way of abrupt or flared bow. Pressure forces caused by green water on deck, particularly on the forecastle deck. The results may be indent of bottom plating, indent in plating on forecastle deck and main deck, in way of pillars inside forecastle. Ships with a relative large depth may be subjected to significant transverse forces. These forces are rolling and pitching forces, acting in transverse direction and causing significant stresses in the transverse bulkheads. Where one hold is empty and the other is full, opposing forces are acting at each side of the transverse bulkhead, causing shear stresses in the ship's side. This is particularly relevant for the open hatch type of bulk carriers and the car carriers. Another type of a dynamic force is sloshing in tanks that are partly filled. Significant additional forces may be set up in the tanks filled with liquid cargo or ballast. This phenomenon takes place when the natural frequency of the liquid coincides with the pitching or rolling mode of the vessel, and no means of hampering the movement of the liquid are introduced, like swash bulkheads in oil tankers. To prevent harmful forces, there may be restrictions on the filling height of tanks. For instance, filling between 20 to 90% of the tank volume may be prohibited. Guidance on how to avoid excessive liquid pressure will usually be issued to the ship as a part of the loading manual. Dynamic forces are very much influenced by the skill and with the care a ship is operated. Good seamanship and competent handling in bad weather are very important factors of reducing the damages on the ship.
Now, you got some idea, okay? Don't worry, nobody's going to ask you about these stresses at this stage. This will come next semester. But I wanted to give a general idea that how why we have got certain things on ships and why there is certain the way it is constructed and all, because you have to consider all this. Now let's see how long it is. Even I don't know, this is too long. This is too long for this. Okay, so tell me, any doubts?
No, sir.
Any clarity came from that old black and white film? It was more or less revision of certain things, and there were some exactly opposite way of doing
Excuse me,
things.
sir.
Huh? Yes.
Yes, sir, I have a doubt.
हाँ बोल.
सर स्ट्रेक और हल में डिफरेंस क्या होता है?
Strake is a strip of the metal. Like suppose this is the strake. Okay. Hull is combination of all the strakes. Strake is like this. A strake one, then second strake is welded here, and the third one like that. So strake is the strip, and hull is the whole thing.
Okay, sir, thank you.
Anybody? Anyone? Anyone? Any
So,
doubts? Yes.
so why there were holes in floors, alternate floors below the inner bottom?
See, correct. What happens is when you make a ship, your idea is to make it light. Okay. Otherwise, ship will become very heavy. Now, okay. The naval ships, you don't consider these things so much because their purpose is different. They have got lot more transfer sections and all, because in case they get damaged during war, they should not be sinking and so on. So they are different. So they had alternate one. We have got lot more lightning holes, because by reducing that much of weight, you take the percentage. Okay. Suppose if everything is solid, okay, no holes anywhere, nothing, and we created a ship. Assume if weight is say 1,000 metric tons, and now I take another ship and I start cutting holes without reducing the strength. It is possible, according to physics, metallurgy, that you can cut holes to make it lighter in weight. So merchant ships have got a lot more. Okay, because we don't consider anybody is going to attack us. So suppose I start cutting holes and reduce the weight by say 30%. That is 300 tons of the less weight to the ship. That means I can load 300 tons more cargo. That is why we keep on cutting holes, but you don't cut holes anywhere you like. There are rules in naval architecture where you can cut and what should be the size of it. Okay?
Okay, sir. Thank you.
And
Anyone?
sir,
Yes.
as sir, the floors and all, that is only the double bottom that we are talking, the framings and all.
No. Floor is the vertical plating inside the tanks. Now it will be in double bottoms. You may have no. Okay, there are different names. Normally, floors will be found only in double bottom. Normally, and then we start calling them web framing and a lot of other words we use. There are lots of terminology in construction. A very boring one because you can't link it up with something to remember it well. Like what web we know, it's something else. Huh? We have got cow webs and all, na? Spiders making webs, and it is something else altogether here. What else? Hmm. Anything else?
No, sir.
No. Okay. Next week you all have tests, right? Next week.
Yes, sir.
Are you going to have classes or without classes?
We don't know, sir.
You
We
don't
don't
know.
know right
Ask
now.
Pal sir.
He said he will inform, sir.
Yeah, okay. He will inform them. I don't know. Means of course you will say that you should have off day so they can study, right? Actually, study habits will have to change, because what you are learning, it should be directly in and it should be extractable. Not forget it after, 1 month, 2 months. So that is what you need in professional things. Like if you go to a doctor and you ask him, I got pain here, pain there, and he says, okay, I will study and I will come and tell you what is wrong with you. You don't like it. You want that guy to give instant answer. So these days, what doctors do generally, they send you for some test to buy some time. Okay, you get this X-ray done and that one, and then he is thinking about it. Okay, that what it may be and all, and so when you meet him next time, by that time he has another opinion on X-ray from another doctor, and plus he has got, then he will see, and that's how it works. Our case also, certain things you can buy time, but there are too many things which must come directly out. Same thing happens, you go to a lawyer, you say ऐसा मैंने किया, so he should give you immediate solution. So that is what is expected in all the professional careers, the immediate solution or quick solutions. Okay,